Hello, this is Eric Lim, the product manager at Whiteblock. We're going to walk you through Whiteblock Genesis, our blockchain testing platform, and show you how to build your own private test network, run tests with impairments, and get the results. Simple and easy. So we're going to start by building out the network using the wb build command. We will do a simple build with 3 nodes in the network. We will also use the default parameters for the network. You can provide N if you wish to customize a network, which will output a list of available options to change. We provided Y here. But while building, the platform is provisioning the nodes, setting up the configurations of those nodes, peering all the nodes, and deploying to the network. Now that the build is completed, we will start mining to start the production of blocks. This will start the miner if the consensus mechanism is proof of work. As we did, you can add the no hang flag here if you want to watch the DAG generation, which just confirmed has been generated. We will also do a quick check by getting the first node's logs, the output of the Pantheon client logs. As you can see, the blocks are correctly being created and shown in the logs. Next, we can simulate the coring of the network by using the wb auto command. So this command will send 250 ETH get balance queries per second from the first node. You set this by noting the interval here, which is 4,000. We can get an overview of the ETH get balance query using the wb get auto command. We can also check the queries with the command wb get auto details flag graph. See, that's working. We then stop the queries by running wb auto purge. Cool. Now we can get the block number. And once we have the block number, we can get the block information by using wb get block. And it will show the block number that was outputted from the last command. The block information will show all sorts of block details, as you can see there. And now we can get to the fun part and start transactions within the network. So the V flag here is the value flag, which we have set to 1. The T flag is the TPS flag, which we have set to 20. That essentially means we are sending 20 transactions per second. We can make sure that the transaction command went through by running wb get running. This command will show the command that is running currently. We now can get the accounts that are in the network. In this build, we have created 50 extra accounts that will be pre-funded in the network. This is important as accounts might run out of balance in a proof of stake network, for example, where accounts are not getting miner rewards and can run out of funds. You can get information about the accounts from the command, including addresses, account balance, public and private key, and the number of transactions that have been sent from that account. Okay. Then we can get the recent transactions that were sent. This will output the latest 5 transactions that were sent to the network. Now we can get the transaction information by running wb get tx info. You will need to copy the transaction hash and paste it into the end of the command. The output will be the transaction details, including from address, to address, gas, nonce, and other information. Then you can get the transaction receipt by using wb get tx receipt. Okay, cool. We will now introduce some network impairments to the network. This command will add a 10 millisecond delay to the network, which is the D flag, and the B flag sets the bandwidth constraints, which we have set to 10 megabytes. We can get some high-level information of our current network by running the wb get stats command after including network configurations. This command that we just used will output the statistics of the last 10 blocks. Going back to the network impairments, we can check the network latency in the network by using the ping command. This command will send ICMP packets and output the time the packets are received from node 0 to node 1. We can see here that this is outputting the 10 milliseconds of latency, which we had set from the netconfig command. Now we can check the bandwidth constraints by running wb iperf 01. Like the previous command, an iperf3 client server will be set up between nodes 0 and 1. This command will show the bandwidth between 2 different machines. Okay, we can now clear the network impairments with the wb netconfig clear command. Cool. Now let's try taking a node out of the network. We do this with wb-netconfig cut 0.1. This will prevent node 0 and node 1 from communicating with each other. And we can prove that they cannot communicate with the ping command again. Okay, so we can see that no packets are being passed. We can bring those nodes back together with the wb-netconfig uncut 0 and 1 command. And we can show now that they communicate with one another using the ping command. Yeah, and you see that there are packets being sent. So this next command here will partition the network. This command in particular will partition nodes 0 and 1 from the rest of the network. And we see that nodes 0 and 1 are still able to communicate with another using ping. But interestingly, when doing the ping command from node 1 to 2, we see that no packets are able to be sent. This is the same when pinging from node 0 to 2. Cool. We will now bring the partitions back using wb-netconfig marry. Now all the nodes that were previously partitioned can now communicate with one another, as can be seen from the ping command. All right. You can get the stats of the whole network using wb-getstatsall. Similar to the wb-getstats past 10 command, this command will show you the statistics of the whole network from the starting block to the current block. Cool. Now let's get the list of accounts by using wb-getAccounts. This would output all the account addresses in the network. Now we'll take an account address and we can send a JSON RPC command that will query the network. This command will send an ETH get balance query from node 0, which will get the balance of the pasted account address. There you have it. So the platform will also allow you to go inside the node with the SSH command. You can see all the directories inside the node. This includes manually changing the configuration file, Genesis file, stopping any processes. You can also, from outside the node, get any arbitrary information from any of the nodes. That command will output the processes that are currently running inside node 1. Cool. There you have it. I hope you have a better sense of how our platform works. This concludes the end of the demo. And if you have any questions, please feel free to reach out and we can follow up and clarify anything that might be confusing or that needs further explanation. Thank you.